Hey, what's going on, folks? It's Mike here, and welcome back to the Programming Language First Impression series, the series in which we look at a programming language for the first time for about an hour or so and just explore it and see what it's all about with a beginner's perspective. Now, today's programming language, little caveat, I looked at it about, a decade ago and wrote some code in it, so it's in my head somewhere, but that language today is going to be Erlang, the highly concurrent programming language, or at least it's used for building highly concurrent systems. That's what it's known for, and I'm really excited about this language, developed by the late Joe Armstrong. And this language itself is in that tier of languages that's a little bit older and more mature, 38 years, but it's still getting stable releases. So I'm recording this in May of 2024, and well, we could see that there was a release about a month ago. So that's really exciting to see that this language is alive and well. And I believe famously it's had some great use cases. I can't remember if it was Facebook or WhatsApp at the time was using Erlang. So we're going to go ahead and dive to the Wikipedia page and see if we can find some interesting anecdotes and learn about this language. Now, if you're building a general purpose, concurrent, functional high-level programming language that's garbage collected, I mean, already that reads pretty well for some of the different things that you might care about. So garbage collection for memory safety. We've got functional programming for, writing what tends to be, programs that we can kind of prove their safety. We're going to see how pure that is as far as the functional style goes. The concurrency, again, which we care about the most, I guess, with this language. That's what it's sort of known for. And of course, it is general purpose, though. Famously, there's an application that I've really loved for a long time, and is how I got started more than 20 years ago with 3D modeling, Wings 3D. So let me see if I can find the Wings 3D wiki, because I believe this was built in, using the Erlang environment. And this is a really underrated 3D tool. Let's see, and it still is pretty active as far as I understand. Every once in a while I'll re-download it, and I still have the shortcut keys in my head from all these years ago because I spent so much time, one of those things when you're younger. But anyways, this is kind of a cool, again, I'm knowing, or I think a lot of people know Erlang for the concurrent features, but again, you could build any sort of application in it. So I just thought that was a cool thing to highlight. And again, something that I really remember, Wings 3D here. So anyway, here's a bird that was built in Erlang. I'd be really curious with the developers for why they chose Erlang, if that was just something they knew, or if they did see some advantage or long-term play here. I think that would be really interesting. So anyways, you could go to the Wings 3D site and maybe ask those questions, or tell them that, hey, some guy on YouTube was talking about your tool. So this is, anyways, pretty cool. Just wanted to highlight that. It's written in Erlang. So again, they must be fans. When you develop software and you're willing to put what language you developed on the front page, that means you must really like or enjoy programming in the language, which I think is pretty cool. So anyways, looks like, this has been an interesting project with a long history, but let's see what else we've got here. So some interesting things here already with the Erlang runtime system. Okay, so it's distributed, fault tolerant. Okay, so if I'm going to build a massively, concurrent system that needs, thousands or hundreds of thousands of users, or millions even, to be using, that seems really important. Soft real time here. So I guess that means guaranteed constraints, just reading from this definition here. I believe Erlang as well is also used for various phone systems too. Let's see if we can find out some of the history of this language here. And I believe that OTP was like one of the libraries or tools, Open Telecom Platform, from Ericsson. Okay, so Ericsson was a Swiss networking and telecommunications company. Okay, great. So we're putting together some of the history here, some of the things that I kind of remember. Let's see. Erlang has, and let me not skip this, the hot swapping. So again, if I've got a code system, I mean, these are things that we like to build ourselves, when I do this in like game programming, right? So you could just basically patch the system while it's live, which is really cool. So if you've got a system with some sort of virtual machine, and the name of that virtual machine is going to come back in my mind in a moment here, or I'll see it here. That's kind of cool if it allows this, since you're compiling code on the fly in the program, this sort of system here. I think it was, Beam, I think is the name of it, but we'll get to that here. Okay, so let's see here. So it's been a Free and open source. Let's see, since at least 1998 here. Okay, interesting here. So let's look at a little bit of the history here. Okay, interesting. The initial version of Erlang was implemented in Prolog. Now, that's a language we haven't looked at, a logic programming language. I know a lot of roboticists who have used that language or learn it, and certainly folks who do it in school. But let's see here. What else we got here? Okay, so yeah, Beam, there it is, the Beam virtual machine here. Let's open that up just for a moment, just to dive into some of these other things. Yeah, Beam, okay, it's got some bytecode here. And what is it short for? Bogdan's Erlang Abstract Machine. Okay, cool. So we're going to have to think about this. And okay, Jam for Joe Armstrong's abstract machine, I guess. All right, interesting. So interesting already. There's been quite a history here. And Beam languages. Okay. And I think some folks have alluded to, I remember Gleam, actually, somebody mentioned in the comments. So, you know, this is going to take us into different places here. Yeah, because this is more recent. Let's see. And is this being used with Elixir or something? Yeah, anyways. Okay, so quite a history here. Here, let's get out of this and back to the wiki here. Okay, so what else we got here? Erlang applications are very lightweight. Erlang processes can be seen as living objects. Okay, with data encapsulation and message passing. Yeah, message passing being the one thing that's always forgotten when we talk about object-oriented programming, right? Objects being able to talk to each other and having support for that. These are some of the things that I remember, and I'm going to have to remember in this hour thinking about Erlang. But let's see what else here. The Erlang runtime system provides strict process isolation. Okay, good. So things I imagine if I want to swap out code or just for safety guarantees, right? If we're, you know, that makes sense to have the process isolation. So this includes the data and garbage collection. Okay. Okay, interesting. Very interesting. Okay, and this is interesting itself that Joe Armstrong, okay, so one of the co-inventors, summarized the principle of properties in his PhD thesis. Okay, so cool to see some work. We've seen a few languages come out of theses. Most recently when we were looking at Elm, for instance, from the authors, I think it was a master's, or maybe it was an undergraduate thesis that language came out of, as well as many other developments. So that's kind of cool. So let's go through these here, and then we'll actually jump into the language and see what kind of materials they have for us to learn here. But let's see. So everything is a process. Okay, so that makes sense. And processes are strongly isolated. Makes sense for safety and so on. Process creation and destruction is a lightweight operation. Okay, so I guess their processes must be carrying around the minimal amount of stuff here. Message passing is the only way for processes to interact. Okay, interesting. So you send messages, they get queued up, and you receive them from the other process. Processes have unique names. Makes sense if we have a concurrent system, right? Just in the same way that we have different phone numbers, right? If we want to connect with each other. If you know the name of a process, you can send it a message. Cool. Processes share no resources. Again, makes sense if you're going to be swapping out resources. You want to avoid contention in these sorts of things, right? So if you're going to build a system like, we'll have to check if it was WhatsApp or Facebook chat that was in Erlang here. Actually, we'll stick around here. So that's kind of interesting. Again, you can't have any contention for that reason. Okay, so error handling is non-local. Oh, interesting. Okay, so more global, I guess. You write an error handler, or maybe a process that handles errors or sends messages. And processes do what they are supposed to do, or they fail. Okay, seems reasonable. Okay, this is great here. Joe, Armstrong, unfortunately, the late Joe Armstrong. I've seen a lot of good talks by him. I think might have been one of the go-to conferences or something, or he's given some talks. But he had all these little bits of wisdoms, and he's got a nice comic also showing concurrency versus parallelism. But let's see. He says, if Java is write once, run everywhere, then Erlang is write once, run forever. Okay, great. Well, we're excited to get into it here. Yeah, here it is. Okay, so Erlang is a programming language used to code WhatsApp. Okay, so that's pretty cool. Erlang is used in RabbitMQ. That's another one. Let's see here. What else? Some notable applications other than Wings 3D. And then Elixir also, which my understanding is builds on top of Erlang here. It shares, some of the same principles, but maybe it's a different syntax or different environment and ecosystem. So interesting. I mean, a lot of interesting places here that Erlang's being used. Let's see some other Erlang success stories. This is kind of cool. Vocalink, so MasterCard company. Okay, cool. Haven't heard of them, but maybe you should know them. Goldman Sachs, Nintendo, Admiral, and so on. So a lot of big companies here. That's kind of interesting to see the usage. I should add Wings 3D here. It's a tool that's been around for 20 plus years. I'd call it a success story. But anyways, sometimes you don't know these things. And again, this is part of looking at different programming languages so that we can uncover, that not everything is just written in, Java, C, and Python. Okay. There are many different languages that are being used. And sometimes it's a competitive advantage to, again, know a few languages or incorporate them in your stack. Okay, here's a factorial algorithm implemented in Erlang. So we'll have to think a little bit on, yes, as I remember, we end everything with the period, just like a sentence. That seems like a reasonable way to do things here. Although this has a semicolon here. Okay, what's going on? So we got our base case and then end here. Yeah, we're going to have to rewire our brain a little bit for the syntax, but, that's just how things are. Okay, so this is the module fact. I don't have to put .erl. And this exports the function fac, let's see, of arity1, one parameter, no type, no name. Okay, interesting here. So the /1 here. Okay, makes enough sense here. Again, a little bit of a syntax thing that you have to figure out here. This must be part of the, I guess if you're just building a module, okay, for factorials and then how to use this. Now, here's our base case. So this is a very recursive language. Interesting. So fac with one parameter when n is greater than 0, and if it is an integer, n. Okay, interesting. Interesting how this works here. Okay, if 0, then return 1. I wonder if I put in -1. How does this handle the error here? Anyways, maybe there's just no case for that. Okay, this function will crash if anything other than non-negative integer is given. Oh, it illustrates the let it crash philosophy in Erlang. Okay, interesting. Well, that answers my question. Good job for, whoever contributed this example here. Note the period, meaning endif or function.end. Okay, that's kind of nice. Yeah, in basic languages, you put explicitly endif or end function or whatever, function end. Okay. Let's look at another example here, and then we'll download it and try it. Let's see. Okay, so Fibonacci sequence, some classic. We're going to export, again, Fibonacci with one parameter, or the arity. Okay, let's see. The general syntax for export is a list containing the name and arity of each public function. Okay, interesting. So I guess everything's, now it's saying here's the public API and here's a private API. I see. Okay, so you write your helper functions here, and I guess you don't export them. Makes sense there. Okay, so let's see. Here's the error handler here. Error negative value. Okay, I wonder if is that a function that someone else wrote, or is that just a special exception type built? However, in this case, we should explicitly prevent a situation that will crash Erlang's runtime engine. Interesting. Okay. Yeah, we'll try some of these or some similar examples out here. Okay, and then we've got our helper function here. When n is less than 3, right, we produce 1 for the Fibonacci sequence. Makes sense. Otherwise, we've got this value here. For all other values, call a private function fib3. Again, that's with 3 parameters to perform the calculation. Okay, so they're getting us adjusted this syntax, right? It's not a division sign. It's so interesting. Okay, so 1, and let's see. Since we're not interested in the value of the second argument, we denote this using an underscore to indicate a don't care value. Okay, so I've seen that in a few different languages. Even D, which I've used, you can use an underscore to indicate, don't care. Sometimes it's just like an empty variable, but I wonder if the compiler is actually looking at that for a special case. That's kind of interesting. Maybe somebody knows here. So anyways, if we just have, let's see here. What's this Fibonacci thing doing here? Okay, I see. When n is 1, we just return the value here because that's just from our little helper function. Okay, makes enough sense here. Let's see here. And then, of course, we've got our Fibonacci sequence. Oh, I see. This is just the accumulator that we're storing here. Okay. and pass it as argument B. Okay, that's the current value, and this is how many things we've done. Okay, so yeah, just got to think about that. Okay, here's the same program without the comments. Hey, this is a nice wiki. I like that, showing it in 2 different views. You probably want like an on and off button here. Again, in this series, something that we're exploring is not only just programming languages, but the ecosystems around it, how they train folks. And already this wiki page is kind of nice here. So I'm kind of learning things about how I want to present code. You know, a with and without comment modes, because sometimes you want to get rid of the clutter and just look at the code. And sometimes you want to say, hey, what's going on with this line here. Okay, so anyways, let's go ahead and just kind of go through this. Okay, so we're going to have different types of things here. Atoms in the language are used within a program to denote distinguished values. Okay, so they're like the smallest indivisible thing. Is that how we want to think about them? Okay, but they're never garbage collected and should be used with caution. Okay, I guess we can't destroy atoms. Maybe that's what the name comes from. We got our basic types here. We've got references. Oh, interesting. They've got like a make ref thing here. So I'm assuming everything is, let's see, references are globally unique symbols whose only properties that they can be compared for equality. Interesting. Interesting. So that's different from like reference semantics here. Okay. Binary, the process ID. Okay, and we can spawn processes. We've got ports, sticks, so like an internet. Functions are function closures. Okay, so we're writing like little lambda looking things or function closures. Tuples. Okay, lists. Okay, with the brackets. Okay, so let's see, DH and then the bar DT denotes a list whose first element is DH and whose remaining elements of the list are DT. Empty list. And that's a short list for, what is this going on here? The first element of the list could be access. Okay, so we're going to have to practice a little bit. We've got maps, strings, records. Okay, and then we're going to have to think about this let it crash coding style. Which is interesting, right? That is an interesting way. I mean, this is the first language. I take that back. We've looked at Ada, which is again known as a very contract-driven language, I would say. And this language fills the space of fault-tolerant. But again, we could argue what that means, the safety in many different languages. Ada was the first one that came to mind here. That's kind of interesting. Okay, so the concurrency and distribution orientation. Okay. Let's see here. There's we're finding a lot of interesting things here again that are kind of new. Let's see. They had a benchmark with 20 million processes with 16 gigs of RAM. That seems pretty good to me. If I can serve 20 million users like on the machine I'm on, my machine's got a little bit more RAM, but that seems pretty good. Why aren't more programs written in Erlang then? I guess is the question here. I wonder how active that system was, but that's kind of cool. Let's see. Oh, it's got some more information here about like 300 words. Okay, interesting. Okay, so this is all interesting stuff here. And then we got to our hot code loading and modules. Yeah, this is pretty cool stuff here. And again, maybe you don't want to use Erlang, but you want to learn about how to do this so you can implement it in your programming language of choice. So that's kind of interesting. Oh, they've got this like code switch thing here that you can do. So if you receive some sort of message for doing a code switch, I guess you can just start running new code here. I mean, I guess it's the equivalent of, other ways that you could implement this, just thinking about it in a language like C, let's say, or D or C++, is to write a code that you load from a shared library, and then you set a new function pointer, right? Which would be that idea. Because you can load and link modules at runtime, no problem. So I wonder, we'll have to think about how this is working. Okay, interesting. Okay, so plenty of interesting stuff here. And it's also pointing us to Lisp. Maybe we'll have to look at Lisp at some point here. But let's go. Let's kind of get started here. We've looked at the wiki here. Already a nice website here. I want to see what's going on in the community. Then we'll spend time coding. Looks like they've got some forums. They've got a Slack and an IRC, which is cool. Again, I just like to see if there's active community in these languages. Like we saw that it's being updated as of last month, so it's regularly being updated. And wow, they've got a lot of different support for IDEs, which is great for learning. This is awesome. Okay, like functional stuff. Ooh, an Erlang masterclass. What's that? Okay, so that's just on YouTube. This is pretty cool. So somebody's done a massively online a MOOC course, open course. Here's the forums, again, looking pretty active. And folks are using this, which is pretty cool. And this is probably what we want. Learn use some Erlang. Or how do I start with Erlang? So let's just open those up here. Those are pretty reasonable. I'm going to read it online, and if we like it, you should probably support this author and buy their text. But let's see what will get us started here. Maybe we'll take a look at that. I think I want to start with probably just running some of these examples here with Homer Simpson. Okay, so those are some nice tutorials that we found. Great. Some applications, some more that they're keeping track of here. Cool. Let's see. Why does rebar sound familiar? Interesting. Okay. They got some package managers and stuff for Elixir. Let's see. Okay, then they've done various events here on Meetup. Codebeam. Oh, interesting. Okay, so they do have a conference here. Most languages have some sort of conference, which I think is useful. What is this? Code sync. Okay, so anyways, I guess that's maybe part of the conferences. Oh, Codebeam. Okay, so if you're in Berlin, I guess later this month, check that out. That sounds cool. Interesting. Okay, and they got all sorts of interesting stuff here with a Beam virtual machines. So I guess that's Elixir and Erlang and so on. Very cool. Erlang Factory. Wow, there's a lot of stuff going on here. And then, of course, there's academic stuff here, but there's the Erlang user conference. Okay, neat. So anyways, yeah, kind of nice. Always nice to be part of a community with these things as you get into language. It's a great way to learn. So, I think I've seen enough to be convinced that, this is a very active and interesting project and language. And by project, I mean the ecosystem around it, right? We've seen that by all these large companies. So nice layout on the website, actively being used. Yeah, I don't know. Let's go ahead and just get started. Let's download this. Let's see how easy it is to get started. Okay, now in Ubuntu, I'm just going to apt-get install Erlang here, or sudo apt-get install it. Let's see if that works. Let's open up a terminal. And yeah, I gotta get permission for this. Type my super secret password. 300 megs, no problem. But we'll go ahead and get that started. Assuming that's all the runtime and all that kind of stuff. So let's let that go. We'll kind of set that up here. Actually, let's move this on the left side so I block as little as possible. Let's go ahead and start looking through. I kind of like this learning in Erlang. Let's start it out here. I've got a little starting out that we can use here. And we'll just kind of dive around here. I like this. This looks like a nice little tutorial as well here. I'll keep that in the background here. So that's what was recommended here. But let's go ahead and go to about this tutorial here. Yeah, this must be, yeah. I began growing the idea after reading Learn You Haskell. Okay, so somebody did that. So what's Erlang? Okay, so we're going to go ahead and probably start this in the shell and then start working on some little programs here. Let's see, functional programming. Okay, so it is a functional language, so we do have to get used to that, right? We've looked at different functional languages, which is interesting. Let's look at this section here. Don't drink too much Kool-Aid. Let's see, what does that mean? There may be many little yellowish orange sections named like this around the book. Erlang is currently gaining lots of popularity due to zealous talks, which may lead people to believe it's more than what it really is. I mean, this is every programming language to some degree, right? We all like our favorites. But this is, yeah, related to the scaling abilities and lightweight processes. Yeah, that's true. That's what this is going to be known for, I'll imagine. And it's going to have more of a linear, I guess that's what they're saying, scaling here. That's more possible if you have lightweight processes. Okay. Well, I like this text. I mean, it's honest. That's what we want here. And it's probably true. Okay. Oh, hey, they're mentioning Wings 3D too. Okay, so anyways, yeah, Erlang is not a silver bullet. Will be particularly bad at things like image and signal processing. Well, we'll see, right? We'll see. And like any language, if you're good at it, you're good at it, and you can probably figure out solutions or whatever. Let's see. So we've installed Erlang at this point, and we'll ask for help as needed. Let's get started out here with some of our shell commands. Okay, cool. They're giving us little helpers here. Okay, so what should we do here? Maybe we'll just type in Erlang. Make sure it's installed. Oh, I forget. Let's see. That tells us. Is it ERL? Yeah, that's what it is. That's what it is. Okay, so let's see. How do we quit this thing? Quit with a period, or just Control C. Okay, Control C twice aborts. Okay, so let's just see if we have some version information here. I guess it's telling us at the start here. 12.2.1. Okay. Okay, let's see. Control A. Okay, so I can move my cursor. Okay, this is giving me some tips here. For navigating the shell, we're going to skip that and start out for real. Yeah, 2 plus 15. Let's put a dot here. 2 plus 15 evaluates it. Okay, interesting. Okay, you should have noticed that Erlang doesn't care if you enter, floating points. Does the right thing here, so it's just got numbers, some built-in functions here. Oh, okay, I guess this is for the integer division here. You're explicit with that. That's kind of interesting. A lot of languages just take this approach with just guessing the types, and then this is explicitly saying, yeah, I wanted to work with integers. I guess that's just by working with these numbers that's like a number type or something. That seems fine. Okay, we got our precedence rules, and then we can do interesting stuff with by specifying the bases. Actually, this is kind of an interesting syntax here, so let's type out a couple of these. Something like that. Okay, that's reasonable. I've seen a lot of different syntaxes for how to represent binary numbers. Like usually you'll do like just type in the number and then just do like or OX for hex and then some sort of number here, or sometimes it's OB and then something like this. This is kind of nice if it allows me to use any sort of base. Again, you're probably using 2, 8, or 16, or 10 again by default for your base, but that's kind of interesting here. If you're able to just use anything. Okay, so Erlang's a good calculator. We know that. Let's create some variables. Invariable variables. Okay. Okay, so this is a functional programming language. So the basic behaviors of variables can be demonstrated with these. Okay, so let's do 1. Okay, so that's unbound. Doesn't exist. Equals 1. Okay, so now if I type in 1, there it is. It is bound. Uno equals 1. Okay, so I can do these sort of multiple assignment things like in other languages. That's fine. Okay, so no problem there. 2. Okay, let's get to the functional nature of this here. And then if I do 2 equals, I try to reassign it. Plus 1. Error. Exception. No match to the right-hand side with value 3. Okay, so equals is equivalent. When I'm creating a new variable, it is that forever, like in math. I mean, this is the functional language thing. The value is bound, I guess, forever here. So again, now this is always the thing to get used to in functional languages, that you bind a variable once, right? It's not like a empty box which you store things in, which is how we teach programming variables in languages that have a lot of state or allow state mutations, like C or something. Okay. So I wonder, let's see here. You can have variables that are only an underscore. Okay. Unlike any other kind of variable, it won't ever store any value. Totally useful for now, but you'll know it exists when we need it. Okay. Yeah, so this is the unbound thing here. Let's kind of keep going here, just kind of keep getting through the language. Atoms. Okay, there's one reason why variable names can't begin with a lowercase. I didn't even think about that here. Atoms, which are little as constants with their own name for each value here. Interesting. Okay. So Erlang's a language we're going to have to take our time with here because it is a little bit different from, C family languages. Okay, let me kind of scroll through this here. Let's see here. Okay, atoms. There's a reason why variable names can't begin with a lowercase character. Atoms, they're literals, constants with their own name for value. Okay, so they're constants. Let's see. What you see is what you get and don't expect more. The atom cat means cat, and that's it. You can't play with it. You can't change it. You can't smash it in pieces. It's a cat. Okay, interesting. Yep, deal with it. Nice. So atom. Okay, let's do these atoms. Rule. So variables. Let's do cat. Cat is cat. Okay. Atoms. Rule at Erlang. Okay, so these are just constants that exist. Okay. An atom should be enclosed in a single quote if it does not begin with a lowercase number. Okay, or lowercase letter. So that's fine. Let's see. Okay, just compare atoms to constants. Okay, that's fair enough. Maybe that's even a better name for const or something. I'm assuming atoms are things that can't be cast away, right? It is pretty firm here that let's deal with it. Atoms are indeed what they are. Okay. Let's see. Having their names as values. Okay, so I wonder if I can create... I mean, I guess these are just like enums or something as well. It's another way to maybe think of them. You need to match name and a constant to some underlying value. Atoms let you forget about underlying values. My eye colors can simply be... Oh, I see. Okay, I understand what they're saying here. So instead of having to use an enum and really have, blue be 1 or something, it's just blue, right, what you're looking for. Okay, makes sense. There's no underlying value here. Don't have to worry about the underlying values never clashing. That's kind of clear. I wonder if other languages are picking up on this idea or have... I'd be really curious if folks have, again, made it this far to comment below if you've seen this idea of an atom in your programming language of choice. Because that's maybe, I wonder if that's a better model than having like enums, which we see in other languages. But it looks like there are some constants that you can deal with. Sometimes it's nice to have the value, like if you want, for instance, like let's say you have a grading system where an A is supposed to be like a 90, a B is an 80 or something. To get that underlying value, be able to like switch back and forth, like to reference either the name or get the underlying value. So I mean, there's purposes for both. Okay, yeah, they're really nice. There are pitfalls too. Okay, so you have an atom table, I guess, that you're sort of building up and doesn't get garbage collected. Okay. So you can have 1 million of these in theory, or whatever the limit is on a 32 or 64-bit system. Okay, so you shouldn't generate these dynamically, but okay, if you need these, they're useful. I like this book. Pretty level-headed approach. Good for this type of series where we want to know what the trade-offs are with different languages and the pros and cons. Okay, Boolean algebra. We got our comparisons: true, false, exclusive or, not false, etc. We could negate these things here. I mean, what a great way for those of you who've taken discrete math, if you could actually just do this in Erlang or something, some language, and use these operators. I know we do a lot of truth tables and stuff, but it's nice to apply it sometimes. It's just kind of cool. Oh, you got and also an or else here for short circuiting. Okay, so otherwise they'll always be evaluated, I guess. Okay, so just have to keep an eye on that. Testing for our quality here. Okay, so different symbols. Let's clear this. I guess we're just at the bottom here. How do I clear this prompt here? That's okay, we'll just live with it. 5 is 5, that's true. Is it equal to 7? No. How about a cat? Is that equal to dog? Okay, I made a syntax error. Let's see, cat. Interesting. It does not. So atoms, I guess, are never equivalent. How do we sort of equate those? Maybe an atom is an atom as a type here. Again, interesting. I'm just playing around with this. Okay, so no worries. Okay, equals and slash equal are there to help you in case. Okay, so we do have equals. Okay, so I guess equals is a little bit more friendly. This is the other thing to highlight versus this, which just is like, yeah, everything matches. We're a little bit more strict. So there is this notion of a float in an int type or something. Versus this is just like, yeah, you met the value 5, we get it. It's the same, even if the values are coming in. So interesting. So I guess that's a programmer decision you have to make. Other languages handle this, right, by doing these implicit conversions, right, for you sometimes behind the hood. Usually where this causes a problem and where you want to be explicit, like in this example, is when you have signed and unsigned numbers that you're comparing, because again, weird things can happen where you have a number wrap around for the like unsigned number, I guess, if you're converting it to a signed. So anyways, okay, let's see. Got your other standard operators for less than, greater than, equal to, and you got some errors if you try to do arithmetic. Okay, so I wonder if there are things like operator overloading and so on. Like, can I write an overload for plus or some operator to handle that in a function? Because I imagine in functional programming languages, again, I think about these in the same way in regular programming languages, but you think about plus as a function, taking in, the one argument here. But let's see here. So it tries to return a nice message here. Bad arithmetic. Okay. Let's see what else we got here. Tuples are in the language. Let's create a point. Well, let's create x equals 10. Okay, so we can do multiple assignments on one line here. Period to end it. Oops, what did I do here? X equals 10, comma, y equals 4. Let's see here. Syntax error before x. What did I do? Oh, maybe just that was leftover. I didn't close that off. Ah, I see. Cat equals dog with a period. Okay, there. Okay, so the atoms do work here. So I wanted to close that loop there. Okay, let's do that. And then we can set a point equal to this tuple. And let's see what we get here. Now, can I just reference these fields here? Let's see if I just do point. Okay, I get it. Point. Let's see. It's going to have x here. I'm just guessing the syntax here. Where did I reference it? Yeah, let's see how we do this here. How do I access the fields of a tuple here? Let's see. This is kind of cool. Two terms. Instead of carrying the variables x and y in place, you only have to carry one instead. Okay. So I guess since, yeah, you're just assigning everything, that's kind of an interesting thing to think about when implementing these things. If basically everything's a table and some sort of lookup, yeah, I don't have to carry around this data structure. I just pass in a point and then I look it up somewhere. So maybe there's a bunch of maps behind the scenes here. Okay, let's see here. So let's see, we got some value that we don't care about here that we are assigning to points here, and I'll get 4 and 5 here. Interesting, interesting. Now what if I do something like, let's see, x underscore equals, I don't know, Bob or something. Okay, Bob is unbound, so that doesn't exist. What if I leave it unbound, so Bob equals x underscore a variable I don't care about? Okay, I have to have it bound to something then. Okay, interesting. I wonder if that's like a common thing that folks wrestle with. I seem to remember getting this error many years ago, and just being like, oh, okay, I'll put in a dummy value or something. Or something's broken on my end, probably, if I'm receiving data or whatever. Okay. Okay, so Erlang's smart enough to unpack values and tuples and distribute them. Okay, and do the comparisons. I mean, that's pretty powerful to see, both sides of this equation, right? It's smart enough to just look at this. X and Y equals point. Okay. And then I can just test their equality. Cool. Okay, let's see here. Note that an expression 6 is anonymous variable. Okay, this is exactly how it's meant to be used. Okay, so it's meant to drop the value. Oh, I see. So it's dropping the value. Okay, and understood. Okay, so we just don't want to care about something. So I can do this, yeah. Or sorry, I can do this. We don't care, and then we just get 4 and 5 back. Okay, but I have this. Let's see. I guess. Let's see. Let's try to see if I make like 2 empty values that I don't care about, and then can I just put a 5 here and then just compare it to 5 because they don't care about some of those? Or do they have to match the amount here? Because imagine that we're just kind of dropping these. Error no match of right-hand side value 5. Interesting. Something like that here. Okay. Interesting. I'll have to play around with this a little bit more. Temperature. Let's see. Celsius. Okay. Okay, let's keep moving on here. Maybe we'll just get a preview of the language as we're typing these out. Lists of the bread and butter. Okay. So yeah, let's do 1, 2, 3. And then I can mix in a tuple. Let's see, with some atom, with another list here. And then like a weird number, and then atom literally here. Oh, let's see, maybe I just messed up the syntax here. Numbers. Oh wow, you can do some pretty wild stuff here. Okay, but they're pretty flexible here. Like in languages where you can have numbers, lists within lists, so anything. Yeah, you can put everything in your wildest dreams in a single structure. That's kind of cool. I mean, it is pretty cool. It is pretty flexible. And it goes for this like code as data thing, right? We saw one of the influences briefly, if you caught it in the wiki, was Lisp, which sort of has this structure, which is kind of neat. So let's keep going here. Let's see here. What else do we got here? Simple enough, right? Oh, let's see here. 97, 98. This looks like an interesting example here. It's gonna give me the ASCII here. Okay. Okay, so you got to do a little bit of work here, I suppose. This is kind of interesting when you think about for applications like a chat server, if they're saying, hey, it's bad at string manipulation because there's no string type. Yeah, I guess, they, as a telecom company, you didn't use strings, right? Okay, so they are just adding stuff and to handle like Unicode and all sorts of symbols. That makes sense. And if you're just using this to pass bytes back and forth, it doesn't really matter, right? So if Erlang's used, again, to back a chat application with thousands and hundreds of thousands or millions in some cases of concurrent users, doesn't matter. You're just passing bytes back and forth as messages, I guess. Now, if you're using it as a front-end application, you probably want, a string library and a good GUI and all those types of things. Okay, let's see. We can glue lists together. We got the concatenation operator. Oops, I forgot my dot. There we go. Okay, so these are all reasonable here. Lists. Okay, so I'm going to kind of move forward here. I think we sort of get the heads and the tails, and I really like these illustrations. List comprehensions. Okay, so we can do some cool stuff. Yeah, now we're getting into some functions. Okay, so let's try some of these out. So for Python, we have something like this here. So I'm going to apply to each of these elements in this list here, this function. Oops, need my dot here. Okay, so that's pretty clean. I like the double bars to separate things. That makes sense here. Which means in. Okay, for the double bars. Yep, becomes the arrow. Okay, and then here's our function. Yeah, this is really, really clean. I like this here. Let's write another one here. Let's take, I don't know, n times n for squaring things. And then I take in, now can I take in something like point? I had that structure here. Let's see what happens there. Oops, let's see. Dot here, exception, bad generator here. Okay, so I couldn't loop through that tuple, I guess. Can I just take in x here? X dot. Somewhere I define x, right? I did, okay. Interesting. Maybe I have to take it in as a list here. X. Okay, and what was the number for x here? Because it's just giving me d. So x was 10, so 10 times 10 is 100. And we saw that ABC is, number 100 is going to be D here. Okay, interesting. Hey, what if I pass this in as a point here? An error occurred. Okay, so I'm just guessing with a dot here. I want to unpack this point here as each list element here. Maybe that's not the point of tuples, I guess. Or for like matching and so on. Okay, anyways, part of this, part of this messing around is to see that, hey, I'm actually getting some interesting errors here. It is unpacking it here, that this is what it's trying to do, multiply these tuples together here. So that's pretty useful if I, pay attention. about, hey, what does this mean here? Okay, so I can't just multiply those. Okay, so good error messages. Languages that are just in time compiled or have virtual machines and runtimes sometimes have a little bit more knowledge, and can give you some useful messages here. Okay, let's see what else we're getting here. We're getting some maps here, some interesting stuff here. I see. Okay, so now we're getting closer here, where we want to take in the tuple that understands the item and the price here. Okay, let's try that with this example that I was doing, where I want to take in the, let's just call it, I'll call it 2x's and 2y's here. I want to take in the, let's see, for the x's and the 2y's, and what do I want to do to them here? This is what I want to evaluate them. I want to say if the price is greater than 3. Let's see here. I just want to take in my point here and do something. Bad generator. Okay. Let's see here. Well, let's maybe start with this example, understanding it. So restaurant menu equals this, a list of things. I guess, it's list comprehension, so maybe I'm forcing a tool that doesn't need this here. Let's just go ahead and call this my points, and I'm going to create a list of lists 1, 2, 3, 4, and 5, 6. And we'll close that off here. Oops, what did I do here? No match of right hand side here. Right. Okay, so let's see. Here's a list equals my points. What did I do to assign these things here? What am I missing? Restaurant menu. Oh, is it because I made it lowercase here? Let me see about the strictness here. My points. Okay, there we go. So yeah, a lot of languages we've looked at haven't been super strict about this sort of syntax, but this is interesting. Okay, so now let's write a list comprehension that says, let's say if this is a tuple with our x and our y. For my points, that's what's going to be taken in, and then for each of the x and the y, what do I want to do with these? Let's just multiply them through this list here. Let's see, so I'm taking in the restaurant menu, and let's see here, let's see, this is doing a test here, I guess, taking in the as input here my points, comma, how do I want to treat this? X greater than 1. Let's start with that here. Something like that here. Okay, so I got nothing here. X less than 1. Okay, so it still gives me nothing. What have I done here? Let's see if I can just get my points back here. Interesting. Okay, so anyways, I might have to leave this example. Let's just try to multiply these. That's what I want. This is what I'm taking in, x and y from my points. Anyways, well, oh, did I mess this up already? I'm putting it in as a tuple. Anyways, so, let's sort of get this example. But let's keep moving on it. We've got 12 minutes on the clock here, and then I need to think about this. Let's see. Oh, this is helpful here to see how this is working. I have the expression and then the generator. So think about these as the generators. And then the condition that follows here. Okay, so you have generator, any number of those, and then any number of conditions that follows here. Okay, interesting. I mean, this is pretty nice. Once I get it working in theory to see how these things work here. Just have to wrap my hand around it for a little bit, but I want to keep us moving. Let's see, bit syntax. Okay, so we got bit types. I want to get to some of the, let's just jump into one of the concurrent examples here. I mean, we made it out from the starting out. Let's hone in on some of the key features like pattern matching. Okay, so this is a big deal here. Instead of writing code like this, I can write it like this here. Okay, so when I greet, just pattern match. So again, here's my input, like my function parameters, I guess I want to say. Okay, we got our IO module here. Let's see if this just works or if I have to import the IO module. Now that I've skipped ahead a few chapters here. Pattern matching is probably one of the big features that every language is fighting for now these days. Let's see here. Greet, mail, name, IO, format. Hello, Mr. And let's see, is this a substitution for the string name? Let's just try this much here. A semicolon. And then let's do, oh, I see. And I mean, this is where the underscore becomes important for the pattern matching. This is like the default case. So if it's male or female or, you know, non-binary or unspecified or whatever, we can specify another case that we want to handle here, or as many as we'd like to enumerate. That's fine. Name. Okay, and let's see. I made a syntax here. Oh, I forgot the. What did I forget here? Maybe these don't work as well in the interpreter here, so we'll just look at them. Let's see here. What am I doing? Yeah, these multi-line things aren't. Do I have to tab them out or something? Let's give it one more try here. Oh, tab. Oh. Shift enter. Okay. IO format. Hello, Mr. Semicolon. Keeps me going. And I'm just going to do the default case to see if we get this working. This looks okay. Greet. Underscore name. IO format. Hello, S name. Okay. Period. Well, I think I've typed it in wrong, but this might not. Syntax error before this one here. I wonder what that means. So that's something I'm struggling with here. I guess it's just treating these as one line at a time or something. But anyways, I probably want to write these out in a module. So it's got pattern matching, which is the big deal, though. And again, as mentioned, most languages are trying to figure out how to get pattern matching because it's seen as more elegant than this. I wonder, from a code gen perspective, if these two things are equivalent. I guess we'll have to see with languages or trying languages that are the same here, if that's true. That's just something I'm kind of curious about. I don't know. I haven't looked at it yet, but I'll be curious. I'll probably look at it in some of the C++ successor languages that have come out that are supposed to be supporting different flavors of pattern matching. CPP2 or Carbon, I think, might even be, looking at those things. But it's a nice feature. I mean, it is more concise. It's just saying, here's the now are these atoms that we're passing in for the different parameters here, and then the name, I guess, is like whatever we specify, and then if we don't have something, we just say hello, which is fine. Okay, interesting. Okay, yeah. Anyways, interesting stuff. Bound and unbound. Okay, so giving us a little bit more on errors here. Let's kind of keep looking through here. Pattern guards, interesting. So I wonder if these are things like template constraints here. Let's just go ahead and take a look at these. Meaning like we want to avoid allowing something to be used. Yeah, I wonder if there is like some sort of constraint here. Anyways, let's look at some of these other things here. What if, let's see, recursion. Okay. Higher order functions. Okay, let's look at a little bit of this functional stuff here. Just get a little bit of a preview. I want to type everything out here. But we can basically pass functions in as parameters, so that's neat. A lot of languages are supporting this these days. Right? Sometimes, and a lot of languages support this through like passing in a function pointer, which is, again, the way to think about it, which is fine. But it really doesn't allow you to compose programs nicely, which is neat. Let's see. I want to do something concurrent here. Okay, key store value here. Hitchhiker's Guide to Concurrency. Oh, what's this? An error message? Whatever. Okay, don't panic. Concepts of concurrency. Let's see if we can find something. This might just be like an introduction. Let's see here. Timer. Just want to see what it looks like to. Okay, so I have like a receive and a send here from an object here. Okay, yeah, this is what I kind of remember from doing Erlang stuff here. Receive. Okay, you receive this message, or maybe this atom do a flip. They're using the pattern matching stuff, and they say no. And then otherwise, you get the other case. You do this, and then this here. I mean, I guess the big thing here with this receive idea here, or send and receive, is that one, it looks like normal code, which is nice, right? Any piece of Erlang code that's running any process, I guess it's just sort of sitting, and maybe you could think of this like an observer pattern, right? Where you've got publisher subscriber model, but or senders, receivers, like different ways of or signals and stuff, like different types of patterns like this. But I guess as soon as you put receive and end, and then maybe send and receive, let's see, here's how we spawn new processes, or these functions as maybe processes. Or modules. Again, I guess there's a bunch of different ways to do this. Interesting. Okay, so we might have to take a little bit of a deeper dive here. I wonder if, where a good place is to start here. I mean, they're going into, okay, I mean, this is a pretty nice book for laying out, setting up the concurrent application. I guess I do want to look at OTP for a second as well. We're coming up on the hour mark here, because I believe this is one of the popular packages for this format here. I seem to remember Erlang having some sort of basic server that you could set up in a few lines, and that was all you needed, which maybe is this here. So anyways, these examples are getting a little bit larger here. And we're gonna actually have to read through the book before you jump into it. So maybe I'll just kind of explore this. I mean, we get to look at the language, mess around with some of the basic types here, watch me mess around with it, and see some of the features here. I mean, hardly any of the features really. Erlang really is a different language than we've looked at in the terms of its model, so I think that's been kind of interesting. But overall, it was easy to get set up with and just start writing programs. I'll have to work through them and maybe look through some of the data structures. This is a nice text, it looks like, for working with all sorts of stuff here. I mean, I wouldn't be surprised if this is the go-to text or whatever. It's listed on their resources. Here's just another example here. And they've got a little module here where they're building some state machines. Anyways, we can look at some of that stuff later here, but Erlang's kind of a nice language. I will say that. And what it allows you to do, it's probably going to take you, it's going to take me, let me speak for myself here, a little bit to understand and kind of rewire my brain a little bit. But I feel like, again, and this is part of this series, exploring some languages for a little bit and then figuring out which one are you going to go do a deeper dive in to really kind of push your brain and try to understand, different things and different ways of programming. I suspect Erlang is one of those good languages to invest some more time in, because of this slogan here, right? We're coming to a parallel or concurrent world and rewiring our brain a little bit to think about how processes communicate, or threads, or whatever system that you're setting up, is probably going to be a useful skill. Some of these skills that people have to think about and architect and aren't necessarily going to be just generated for us. Erlang in that way is a very interesting language. So anyways, I'll go ahead and close it off there. Let's close it off again at the about page for Erlang here. Hopefully you've enjoyed this. So I'd be really curious to hear your thoughts about Erlang, right? You could probably get further and look at some of the list comprehension stuff and the pattern matching, and let me know if you've used Erlang for anything interesting in the comments. I'd be really curious to hear what folks are using it for, or if you're using some of the variants or other languages like Elixir, or maybe if you recommend starting with Elixir and then coming back to Erlang, or vice versa. I'd be really curious to hear what folks who are more familiar with the ecosystem think about. So anyways, folks, there you have it. Hopefully you enjoyed that video, an hour or so of exploring Erlang. I had fun. I thought it was a really neat language to explore and just think a little bit different, right? Because I'm always thinking in sort of C family languages, but taking a look at some of these languages and just thinking about, yeah, this is message passing, and it's kind of nice how it's built in. Some languages, again, like D have it, but Erlang really, takes it to the nth degree, right? That's what it was for. So anyways, folks, I'll leave it there. Hope you enjoyed that. Thank you, as always, for your time and attention, and let me know if you made it to the end of this video in the comments below. Alrighty, folks, take care, and we'll see you in the next one.